This is the final project of pre-calc, and today I'm going to be teaching matrices and row operations. So, first off, a general matrix is often seen as this: A, B, C, D. And basically you put in numbers to replace those variables. So there are three basic transformations. Any two rows may be interchanged. The second one is any row may be changed by adding to its element as a multiple of the corresponding elements of another row. The third is the elements of a row may be multiplied by a non-zero number. What are the basics of a matrix? What do we need to know about matrices? Well, one is that, obviously the formula, A, B, C, D. And also the second one is knowing the dimensions. So basically we know the dimensions by knowing the rows and the columns. The rows and the columns are often represented as the first number and the second number. And so that's basically it. So let's look at the first transformation, which is any two rows may be interchanged. Now, the first is row switching. This transformation is represented by the arrow between the two representations of the matrices. This can only be done between rows with the same dimension. Interchanging rows does not change the solution to the system. And switching rows by a simple arrow, interchanging rows does not change the solution to the system. So, how do you do row switching? Basically, what you do is that you just have to switch rows. And so, in this, we can see that these are rows. Each of these individual lines of numbers are rows. And we can see that these are columns. So, basically what we need to know from this is that row switching is important into making a matrix more understandable and organized. Now, let's move on to the second one. The second one refers to the second basic transformation, which says any row may be changed by adding to its elements as a multiple of the corresponding elements of another row. So, basically, that's saying that we have to add and subtract matrices. So, here are the rules of addition and subtraction. The first we need to know is that two matrices may be added or subtracted only if they have the same dimensions. As we know from learning the basics, we know that it has to have the same number of rows and columns. The second rule is that addition or subtraction is accomplished by adding or subtracting corresponding elements. For the second rule, we'll see this when we solve for adding two matrices together. As we can see here, we can see that both rules apply. So, with addition, you see that A is equal to 1, 2, 3, 7, 8, 9. B is equal to 5, 6, 7, 3, 4, 5. Now, what we're supposed to find is the sum of both matrices. So basically, this is where the second rule applies to. We have to add where each of them are corresponding. So, we see if we place both of these matrices on top of each other, we would see that they have corresponding numbers. So, this one would have to be added to the 5. This 2 would have to be added to 6. This 3 would have to be added to 7. This 7 would have to be added to 3. This 8 would have to be added by 4. This 9 has to be added to the 5. This is how you get the solution 6, 8, 10, 10, 12, 14. The solution's dimensions would not change at all within adding and subtracting matrices. We can also see this in subtraction. We can see that when you do A minus B, that it subtracts by the corresponding numbers. However, it is important to note that you are still adding, yet you are converting B into a negative. What I mean by that is that A still stays a positive, as you can see, which is indicated in the problem. 1 is still positive. However, B, 5, is negative. 6 is negative. 7 is negative, and so on. So, this is basically subtracting, yet you have to be conscious about the organization of the matrix in the dimensions. As you can see, subtraction also upholds the dimensions that are shown. A harder example of adding and subtracting would also be this. So, let's do this together. Consider the matrices shown below, A, B, C, and D. A is 1, 2. However, we can see the dimensions are 2, 1. B is 3, 5, 4, 6. We can see that the dimensions are 2 by 2. C is 4, 5, 6, 6. We can also see that these dimensions are 2 by 2. D is negative 1, 0, negative 2, 0. And we can see that this is 2 by 2. Which of the following statements are true? A plus B is equal to C. B plus C is equal to D. B minus C is equal to D. I'll give you guys some time so you can work this out, or you can just pause the video. As we can see, this is a true or false question. We have to cancel out which ones are not true. So let's look at the first one. I. A plus B is equal to C. Well, we can see that that is impossible because this is a 2 by 1 and this is a 2 by 2. So, as you can see from the first rule of addition and subtraction, that two matrices may be added or subtracted only if they have the same dimensions. So, we can tell that this cannot be true. So we can cancel A, D, and E. Let's look at number 2. B plus C is equal to D. Well, as we can see that we are able to add both of them. However, we see that this is adding. And how are we able to get a negative by adding two positives? That is the flaw in this. So we can be sure that I cannot be true. So that means B and D are both not true. And so that only leaves us C. If you want to work it out, we can work it out together. Anyways, so B and C. If we subtract these two, we would know that C will become a negative. And so if you add negative 4 by 3, that'll be negative 1. If we go 5 minus 5, it'll be 0. If we go 4 minus 6, that'll be negative 2. If we go 6 minus 6, that'll be 0. And so, we know for sure that C is right. Now, it is time for us to go to the third transformation. The element of one row may be multiplied by a non-zero number. What this means is we are able to use multiplication and division for the third transformation. In matrix algebra, there are two matrix multiplication of a matrix by another matrix. When you multiply a matrix by a number, you multiply every element in the matrix by the same number. So, what this means is that when you multiply a matrix by a number, you multiply each element within that matrix by the same number. This can be seen like that. So, it is often resembled as x times a. And we can see that within this problem, 3 times a, that matrix A is being multiplied by 3. So, what do you do with this? Well, with this information, you would multiply each of the elements, 3, 8, 4, 9, by 3. You can see here that I've already done the work, and that would be 3 times 3, 8 times 3, 4 times 3, 9 times 3, which will leave you 9, 24, 12, 27. What's important to notice is that when you multiply 3, you do not change the dimension at all. Another form of multiplication is multiplying by matrices. How would you multiply two matrices? Well, as you can see, the matrix A and B is defined when the number of columns in A is equal to the number of rows in B. That means that if the number of columns in A is not equal to the rows in B, it cannot be multiplied or divided. So, we can see this in here. Here is the equation in which you multiply a matrix by a matrix. So each of these terms represent the order of operations you would take. C and IK, the element in row I and the column K in matrix C. A, I, J, the element in row I and column J from matrix A. B, J, K, the element in row J and column K in matrix B. Sum of J, the summation sign, which indicates the A, I, J, B, J, K terms should be summed over J. Now, this would all make sense once we do the problem ourselves. So, here's our example. Suppose we want to compute AB given the matrix below. A, which is 0, 1, 2, 3, 4, 5, and B, which is 6, 7, 8, 9, 10, 11. So, what we'll do is use a formula from the last slide. When we use CIK, which is equal to the summation of J, A, I, J, B, J, K. Now, as we can see, we know the dimensions. This is 2 and 3. This is 3 and 2. Because A has 2 rows, we would know that C will have 2 rows also. We also know that because B has 2 columns, we know that C will have 2 columns. To compute the value of every element in 2 by 2 matrix by using this formula. As you can see, what we did was to multiply row elements in matrix A by corresponding column elements in matrix B. What that means is that we multiply 0 and 6 when also we multiply 1 and 8, 2 and 10. And we add all of those, which is the summation of the equation, and we'll get 28. Now this will all make sense once we finish. So, for the second one, we go 0 times 7, 1 times 9, 2 times 11, which will add up to 31. Now, we have to go 3 times 6, 4 times 8, and 5 times 10. Now, for the last one, we have to multiply 3 times 7, 4 times 9, 5 times 11, which adds up to 112. Now, what are these random numbers? Well, we know that C is a 2 by 2 matrix. So the solution of the multiplication of the two matrices would be C, which is 28, 31, 100, and 112. So what we did in the end was multiply row elements in matrix A by corresponding column elements in matrix B. Here's our sources. And if you need additional help, you can go to either one of these and find more help on better understanding matrices and its row of operations. Have a good day.